Okay. All right, welcome everyone to learn.py session 8, standard library and packages. This is our final session. So yeah, it's been a great ride with everyone, and let's make this a great 2 hours. As always, you can find the link to the slides and the link to our README here. For this session is bra_momentum. If you're still keeping up with the ACM member point stuff. And our feedback form is also linked on this slide. Yeah, this is obviously we're not going to have any more learn.py sessions, but if you fill out the feedback form, number 1, it's your final chance to earn money, which is awesome as always. And then number 2, it will just help us for future workshops. We've really tried to incorporate all the feedback we've gotten over the last 8 sessions. So we will definitely pay close attention and look at that. Okay, so for a quick last week, Tim did web development part 2. They did an awesome job with that. And this week, Chandra and I are going to be doing standard library and packages. So the only things you'll need today is just Python and VS Code or any text editor of your choice, and that's it. And then finally, just one more quick thing is all of the stuff that we're going to be doing today. Well, I think Chandra will have a little bit more detail about his, but for mine, for sure, you can definitely code along. But if you end up falling behind, that's totally fine. You can also just watch. I'm going to be showing, I'm going to be commenting and my outputs and stuff. And the code is also in the same repository as the README link a couple slides ago. So you can always go back and look at it. And if not, that's totally fine too. This is a beautiful meme Chandra made. Okay, so for today's plan, for my part, I'm just going to give a quick couple library shout outs, just very quick, and then I'm going to preview a couple libraries that I'm going to be using in my demo. And then I'm actually going to give the demo, and that's going to involve NumPy and Matpotlib and a couple more libraries that I will be discussing. And then for part 2, obviously Chandra will talk about it more, but he's going to be going over more standard libraries, Tensorflow and Opencv. So here's one more important note. The libraries that we're talking to you about are huge, and like if we tried to encapsulate everything about the library into like a couple slides or something, we would be doing you a disservice. So for some of the libraries that I'm talking about on the slide and in the README, I provided just like a link to the docs for that library, and you can also just Google it. So yeah, definitely like right now we're just trying to plant the seed of the library in your brain so that like one day when you're working on a Python program, you can think like, oh, wait a minute, that guy was talking about that one library that was used for this one thing. And then you can like look it up and figure it all out. And so yeah, we're just like showing you that these libraries basically that they exist. Oh, sorry, I have like the progress thing right here. So that's what's in bold. So again, the following few slides are meant to be a very brief introduction to a few libraries that you may find useful in your near future. So I put some great imagery here, planting a seed in your brain. It's a sample. You're getting your feet wet with the libraries, just very basic descriptions. And sorry, I have a lot of intro things to talk about. One last thing I promise is within a Python file or interpreter, you can run the commands dir and then put whatever module name it in there, and it will return a list of all that module's functions. And you can also run help with the module name, and that will return an extensive manual page for that module. So if you have any questions, you can look it up Python as well. Okay, so our first library is OS. OS is basically just a library that provides a bunch of functions for interacting with the operating system. So that means stuff like making directories, listing directory contents, getting working directories, and much more. And the way you import it is with just import OS, and then obviously the link for the documentation is right here. If you go to the slides or the README, you will be able to find that. Basically what I'm going to do for each of the libraries is just give like a very short description, and then leave you with the documentation if you want it, and basically move on, just so that you can kind of just get a little idea of what it is. So our next library is for if you're interested in checking performance, which is the timeit library. And so an example of something you could do is from timeit import timer, and then run timer, and you put the commands that you want to check within the string here, and then you do .timeit. And I'm actually going to do just a quick demo of that. Let me just open VS Code. Have to share my connection thing, right? It's clearly something. Whoa. Okay. Okay. Oh, people are in the waiting room, I guess. What is going on?
I think it should be good to go now. It looks like it's being recorded.
Okay. I'm just going to keep talking, and if we run into more problems, then that's that. I'm just going to quickly admit the people in the waiting room.
Here, I'll manage like the waiting room stuff.
Okay, sounds good.
Go ahead and get started. Yeah.
Yep. Okay, so let me just go into VS Code. Oh, I have to share my screen again. Okay. Okay, and I can't move. Okay, I have to share my other desktop. This is really interesting. Okay. So all we need to do is from, oh my goodness, okay. From timeit, or let me make the font a little bigger. Import timer, and then give me 1 sec, sorry. Okay, then let's just try printing 2 different commands. So we'll try to do the same thing twice. We'll do timer, and we'll time just changing or just switching the values of 2 variables. So we'll do it like kind of the C way, which is with a third variable that you use as like a go-between. So T equals A equals B, and then B equals T. And this is where, let's just say A equals 1 and B equals 2. Okay.
This recording should look interesting.
Yeah.
It's okay. Just try to continue on.
Yeah. Okay. So we have our command laid out. Let's timeit. .timeit. Okay, and then let's just do the same thing, but the Python way, which is just doing A comma B equals B comma A. And in this scenario, we also have A equals 1 and B equals 2. And then we have to time it. Loading some. here. So the first command of time it. Okay, sure. Can I?
Yeah.
Cool. Awesome. Okay. So one ID uh, should you can that was part one. That was just like a couple super brief technical issues. That I'm going to be using. So you may be asking, it's like mathematical constants and functions. You know, generating as it sounds, this literally, you know, it's just like mathematical like that. And other cool random stuff like random sampling, which and basically a bunch of stuff that you did in AP Stats that you don't want to think about, but probably will have to think about again at some point. Okay, and then let's look a little bit closer into NumPy, which is one of the libraries that I'm going to be using. Of more advanced math and logical operations, especially on arrays. That's kind of like one of its special. The typical way people use it is import NumPy as MP, and then again, the documentation for it is right there. There's a ton of stuff to it, and you know, I'm just going to give like a super brief summary on the next slide, but a couple of the things that it does. So some of the cool things it does. One of the cool things about NumPy is the ND array, which is a n-dimensional array, where each dimension is an axis. So that basically allows you to have arrays of, you know, many different dimensions. And NumPy has, Chandra is going to be using some of that functionality during, so, you know, I'll leave that to him. Another thing that NumPy has is it has this function called arrange, which basically it returns an ND array, n-dimensional array of evenly spaced values. So it returns from like the start to an end, basically, yeah, how much space is in between each value. And we'll be using that when we're graphing. And then finally, it also just has some basic math functions. It has, you know, numpy.sine, cosine, pi, etc., etc. Okay, and then finally, the last thing we have to talk about quickly before we start demoing is Matpotlib, which is a library for creating graphs in Python. And basically, the best way to think about it is like you can control every single aspect of the graph that you could ever think of. I just like kind of looked up some cool Matplotlib graphs. These are far more advanced than the ones that we're going to be making, because this is probably a bunch of code and these look really cool. But we're just going to be making some really basic Matplotlib graphs just to kind of show you some of the cool stuff that it can do. So let me, okay. Nope, I did not want to do that. Okay, can everyone see everything now? I hope. And then if like the font is too small or anything, just make sure to let me know in the chat, and I'll make it bigger. I've had problems with that in the past. So let's start graphing stuff. Matplotlib.pyplot as plt. Nope, as plt. Oh my goodness. Okay, and then we're going to import NumPy as np. Autocorrect. We're going to be using random. We are going to be using math, and then we are going to be using statistics. And remember for statistics that you need to install it first, or at least I did. So let's start with graphing something really, really basic. We'll just do x equals mpy and then numpy, and then we're just going to generate a range from 0.0 to 2 times numpy.py with steps of 0.1. So we're just generating a range from 0 to 2 pi, and that's going to be our x values. And then for our y values, we can just let's just graph sine. So we can just do numpy.sine x. Okay, and then so if we have our x and our y values, literally all we need to do now is plt.plot x comma y, and that will create a plot for us. And then I get, you know, we can add a title, and we'll call it sine graph. Okay, and then finally we just have to do plot.show, and that is all of it. So let's try running this right now and seeing. Okay, so let me make this bigger. This is our sine graph. Cool. So this is pretty basic stuff. Let's do a little bit more. Let's see what else we can do. So the cool thing about Matplotlib is that you can have multiple graphs in the same like image. And the way that you can do that is by using this method called subplot. And so it basically creates a grid, and each plot that you create will be added to the grid. So if I wanted to create 4 graphs, I could do 2, 2, which will create a 2 by 2 grid. And then the graph that we're going to be plotting right now is the first graph. So we'll do 1. So this is going to be our first graph. Now let's do our second graph. So we'll do math subplot 2, 2. We're keeping our 2 by 2 grid, but now we're going to do 2 for the second one. Okay, and this time let's do the same thing as here. We'll generate a range from 0 to 2 pi, but let's just have some random data this time. So we can just generate a list of random, and then the random function that we're going to use is called randRange. And what that does is it generates an integer between the range that you provide. So we'll generate an integer from -10 to 10, and then we'll do that for I in the range from 0 to the length of x. So what this big statement is doing is for every single value in x, we're going to generate a y value that is just a random number between -10 and 10. So our graph's probably going to look like really weird, but that's okay. And then all we have to do again is just plot x and y, and we'll give it a title, which is going to be random. Okay, so if everything works right now, we should get 2 graphs on top and then 2 blank spaces on bottom because we don't have any graphs there. Something in the chat. Can I make font a little bigger? Yes, absolutely. Wow. Okay, that's pretty big. Is that big enough? I hope. Okay, so let's try running this. Oh, I think I wasn't in VS Code. What is happening? Is my computer being slow? Huh. I may have an error somewhere. Okay. It's not letting me exit out of the command. Let me open up a new terminal and see if that fixes it. Okay. Oh. I have no idea what's going on. Trash can. I will do that. Okay, let's try again. Okay, I don't know what was wrong, but that fixed it. Thank you, Einar. So now we have our 2 graphs. Wow, this is like a really cute graph here. But this is what we wanted. We wanted 2 graphs and then 2 empty spaces below those 2 graphs. So yeah, I was going to make 4, but maybe we'll just make 3. The next one I wanted to make is, so we'll initialize it for a subplot. We'll do 2, 2, and then this is our 3rd one. And what we'll do is we'll try to use the statistics module just to generate some means and medians from data. So let's get a couple sets of data. The first one we can do random.randRange from 0 to 15. And we'll do that for I in a range from 1 to 10. So we're generating 10 values, all of them a random number between 0 and 15. For data 2, we can do the same thing, but let's just do 0 to 30. And then for data 3, we can do the same thing again, but we can do it from 0 to 60. Just so we can see the difference in them all. Okay, and then for this one, let's just say I want to make a bar graph with each of the means and medians of each of the sets of data. So let's first initialize the x-axis, which is going to be our titles, right? So we have D1 mean. Let me put it in a Okay, we have D1 median. We have the same thing again, except for, let me just change these to 2s and these to 3s. Okay, and then let's initialize our y-axis, which is going to be the actual values of each thing. So for D1 mean, we have to do statistics dot mean of data 1. For, actually, you know what I'm going to do? I'm going to, so I don't have to write statistics every time, I'm just going to do from statistics, import mean and median. Okay, then that way I can just do this. So we can do, okay, then we do median data 1, mean of data 2, median of data 2, and mean of data 3, and median of data 3. Okay, so we have our X and Y values. Now, instead of using plot, we're going to use bar. So it's plot.bar and then X-axis and Y-axis. Okay, and then, oh, let's add a title quickly. So we have plot.title, and it's going to be, what's a good title? Bar graph. Cool. So let's run this and see what happens. Wonder if I'm going to get that weird thing again. It looks like I am. So let's trash this and then run again. Oh, I know why. It's because I'm not closing the Matplotlib graphs. That's why. Silly me. Okay. So cool. We have our bar graph here now too. We have the mean of data 1, the median of data 1, the mean of data 2, the median of data 2, and the mean of data 3, and the median of data 3. I think, you know, obviously these bars should look different if we do the same thing again, because the random generation will be different. So let's try that. And it is a little bit different. See, this is a lot higher, and then now the mean's higher. So yeah, that's kind of just an example of how to do a bar graph. And then I was going to make one more graph, but we're running a little short on time, so I think I'm going to move on to the last thing I wanted to do, which in my opinion is a little bit cooler. So this is you know, an example of having multiple graphs, multiple types of graphs, and you know, just graphing some random data, taking some statistics of it all. But the thing is, all of our data is randomly generated, and I think it would be cooler to work with some actual data. So let's create a new file, and we'll name it in a sec, actually. Let's go, let's just like, I'll give you a scenario. Say that you work for a company and your boss, so like, let's just say you work for Nickelodeon, right? And your boss tells you, you know, they're trying to figure out who's going to, you know, what show they should play on the Saturday morning cartoons or whatever, right? And someone says SpongeBob and someone says Paw Patrol, which is another Nickelodeon show. I've never seen it before, but I'm pretty sure it's bad. So you're like really anti Paw Patrol, right? So you want to prove to your boss that SpongeBob is way better than Paw Patrol. So you do, so one thing that you could do is you can show them a graph that shows, oh, you know, SpongeBob is way more popular, way more important, whatever. So one cool thing that we can do is we can, you know, we can measure the Google searches of both of those terms. So we can go to Google Trends, which is where Google shows their search, basically like the history of searches. So, and let's just type in SpongeBob. And this is the graph over the last, you know, 12 months in the United States of the search history of SpongeBob. So let's just make it 2004 to present, you know, so we get more data, and let's make it worldwide. And then for our second parameter, let's add Paw Patrol just to see, you know, the comparison. No beef, just comparison. And so this is a cool graph. Like you could just take this and show it to your boss, right? So let's just say I took a screenshot and I sent it to my boss. And then your boss sends you a strongly worded email that says, why would you just, you know, why wouldn't you make your own graph? This graph sucks. It's so ugly, whatever, you know, yada, yada, yada. Paw Patrol. No, wait, Paw Patrol, my bad. So your boss just hates this graph for some reason. I don't know. Maybe he just is a stickler for Google Trends or something. I don't know. But let's try to recreate this graph and just make it way better. Okay. So the cool thing about Google Trends is they allow you to download this data. So we're going to download this data as a CSV file. And then I'm just going to put it on my desktop for a sec. And I'm going to rename it sponge verse paw.csv. And then another thing that you should make sure to do, just because as I was trying this is what happened, is go into the CSV file and this is what the data looks like. It's probably really small, I'm sorry. But just delete the first 2 rows because it just messes everything up and it's not the actual data. So now we have our actual data. Let's start making this graph. So I'm gonna start by importing everything we're gonna need. So we're gonna import matplotlib.dates as dates. And the reason we're doing that is because eventually we're going, oh, I have to name the file. Sponge verse paw.py. Okay, so the reason we're going to do that is because the dates that they provide us, we're going to have to convert into numbers in order to graph them properly. Okay, so we're also going to import matplotlib.pyplot as plt, and we're going to import NumPy as MP. I don't know why autocorrect is still doing that to me. And we're going to import datetime as datetime. So same thing, we're going to use that to convert the dates into actual numbers. Oh, and then we also need to import CSV. Okay, now we have all our imports. Let's just start by generating our arrays or our lists where we're going to have the data. So we're going to have our SpongeBob dates. We're going to have our SpongeBob scores, which is basically on the graph. The score is the Y value. It's like it's a score that they generate that measures how often something is being searched. So sponge scores is going to go here, and then we're going to have paw dates, and we're going to have paw scores. Okay, now we're going to open the file. So we're going to do with open, and then I'm going to type in the path to my file. So I put it on my desktop. So I'm going to do desktop slash, or actually, you know what? This is a good opportunity to show OS. So instead, we can change directories. So we can os.changedir into desktop. And then once we're in desktop, we can access our file straight up. What did we end up calling it? Sponge underscore versus underscore paw. So sponge underscore versus underscore paw dot CSV. And we are going to be reading it. Okay, and we're using it as file. What is this error? Nothing. Awesome. Okay, so now we're going to create our dict reader object, which is going to help us read through the CSV file. Okay, and then for each column in CSV reader, what's going on here? Oh, CSV dot dict reader. There we go. For each column in CSV Reader, we're going to append to sponge dates. What are we going to append? We're going to append the column called month. Okay. And we're going to do the same thing for Paw Patrol dates because they have the same dates. All right. Okay, and then for sponge scores, we're going to append the column. We have to cast it as a float first, and then we're going to append the column called sponge worldwide. That's what they called it. Okay. Then we're going to do the same thing for Paw Patrol scores, but obviously with the Paw Patrol's column. So we're going to do Paw scores and Paw Patrol worldwide. Excellent. Oh, and actually one thing is if you look in the CSV file or in the CSV data, sometimes obviously Paw Patrol is going to be 0 because I guess it didn't exist. Oh yeah, I think it was like created in 2013. And so the value here, if you look really close, it's probably really hard to see, but it's under 1. So we have to add a kind of an extra check for this one, which is if call Paw Patrol worldwide is if this column is equal to 1, then oops, forgot my colon. Instead of appending whatever's there, we want to append 0. Because appending, like you can't cast this as a float because it's a string and blah, blah, blah. So, and otherwise, we just want to do the normal thing. Okay, so now we have all of our data in sponge scores and paw scores, right? But the thing is, our dates are messed up because if we try to graph just a date, it won't work. So we need to convert it into an actual number so that Matplotlib can process it. So for date in sponge underscore dates, we want to do date equals date time dot date time. They name the module and the class the same thing, so we have to do date time dot date time, and then we're going to strip time, and we're going to do date, comma, and then we're gonna put in the format that it's currently in. So the current format, if we look back, is okay. For some reason, it looks different here, but if you look in the CSV file, the format of each of the months, I'm sorry if it's difficult to see, it's the year and then dash and the month. So here we're going to provide year dash month. And that's it. So that will convert it. Okay, and then we're just going to do the same exact thing for paw dates. Okay, so now we should be able to use the plot date function because we converted to date time objects, and we're going to plot sponge dates and sponge scores. And then let me think for a second, sorry. In order to keep it in a format, oh, I remember. In order to keep it from using a scatter plot, the specific style that we have to use is B-. I should know what it stands for and I don't, so my apologies for that. And then the other parameters that we have to access for plot date is we have to say X date equals true because our dates are going to be on the x-axis, and we have to say Y date equals false. Okay. And then we'll also just, let's add, actually, you know what, we'll add a label later. Let's just get the graph first. Okay, then we're going to do the same exact thing for paw. Okay, and am I missing anything? I don't think so. For now, let's just plot.show and see what we get, and then we'll fix it up later. So let's graph it. Oh, did I forget to delete the old graph? That's possible. Okay. What happened? No such file. Oh, do I have to put /desktop? Let's try again. No. Interesting. I don't know why that's not working.
Is it because you're in the desktop already?
That is possible. Let me comment this out and try running it. Okay. Different error. Oh, I know what that error is. It's SpongeBob, not Sponge. Good save, Eugene. Thank you. Okay, so if we weren't in desktop, we could change our directory to desktop, but we are already there. Oh yeah, I see that. Okay, it's right there. My bad. So let's run this. Oh my goodness. Oh, I should not be in this folder. Okay. Let me uncomment this and see if it works. Oy vey. CD.
I think now you might have to get rid of the slash before desktop.
Oh, I see. Okay. Okay. This should work. Okay, let's see what's wrong. X and Y should have the same. Huh. I'm not sure what the problem is.
Were there more data points for Paw Patrol than SpongeBob?
Yes, but it shouldn't. When I tried it before, it didn't matter.
Okay. What was your y-axis again for both of the plots?
Y-axis for both of the plots is scores. Oh, did I forget to change? No.
Sponge dates. Oh, you put sponge dates.pen twice.
Nice. Good save again. Okay. Apologies. This should fix it. I really hope. Okay, good. Yes, we have the ugly graph that we wanted. Okay, so this graph has a lot of problems for a lot of reasons, right? We're going to fix them all really quickly so Chandra has enough time. So number one, we want to add like a legend or something. Number two, we want to make them different colors. Number three, what is going on down here? That's crazy stuff. So let's just start fixing these issues one by one very quickly. So number one, in order for us to add our legend, we have to set a label, and we'll label this one SpongeBob, and we'll label this one Paw Patrol. Okay. And then let's also add a color. So we'll make this color gold, and this color blue. Okay. And then now that we have the labels, we can add a legend, but we can also add a couple other things. So we can add a margin so that if you look, like there's this weird space here and here, we can fix that super fast. We'll set x equals 0. And then we can add our plot.legend easily. And then let's also just add a couple nice things like a title. We'll title it SpongeBob versus Paw Patrol popularity. Okay, we can add an X label, which will be date in the form of year-month. And I mean, obviously all this stuff is a little bit unnecessary, but it just makes the graph look nicer. It's easier for people looking at it to understand. We'll add our Y label to be relative popularity, which is just like a Google Trends score. Why is this not capitalizing? There we go. Okay, what else did we want to fix? Okay, the last thing that I think we should fix is the X ticks. Remember, everything's super bunched up here. So we can use a function called xticks to fix that. So it's just plot.xticks. And all we have to do is we can actually use the arrange function from NumPy, and we'll just make it from 0 to the length of sponge dates, which is the same as the length as of Paw Patrol dates. And sorry, length +1, comma 12. That way it will do every 12 instead of every single one. And the reason I picked 12 is just because there's 12 months in a year. So we'll see 1 tick per year. And then the other thing we can fix is we can actually rotate the X ticks. So yeah, that's, did I not import NumPy? I did. There's probably a syntax error. Okay, so just quickly for this line, we made it, the ticks go every 12 instead of every single one, and we rotated our X ticks 40 degrees so that they're not all like bunching up together. So let's run this and see what happens. I forgot to cancel out of the old one again. Okay. Okay, I'm just gonna trash it. No such file desktop. Oh, because I'm already in it this time. Okay, I see now. Okay. There we go. Okay, now we have this beautiful graph that that we've generated, and there's like 2 more things that I want to fix, which is I want to add a grid, and then let's try to fill in everything under the graph. That's, again, super fast fixes, and those are done with the fill between methods, sponge dates. So we can fill between sponge dates and sponge scores. And what do we want? We want our color. Let's just make the fill color yellow. And then in order to make it a little bit, we can actually make it like a little bit transparent too with the alpha parameter, and we'll just make it 0.5. And then I'm gonna write it this time because I've had some copying errors. And then we can do the same thing here. So we can do paw dates, paw scores. Let's make our color. What's a good color that's not blue? Teal. And we'll do alpha equals 0.5 again. And then all we have to do to generate the grid is plot.grid. And this should be our finalized graph. Let's see. Let me delete the old one and run. Beautiful. Okay, so check it out. This graph, in my personal opinion, is way better than the old graph. So if you just kind of compare them side by side, that's the old graph. This is our new graph. You know, we have a title, we have way more ticks that show, you know, we have nicer colors, we have a y-axis label, we have a legend, you know, all the stuff that this old graph didn't. And so, yeah, I just kind of wanted to give a little bit of a demonstration of some of the like graph beautifying aspects of Matplotlib. And yeah, that is pretty much it for me. So I will pass it off to Chandra.
All right, that was a very beautiful graph. Yeah, and you know, one day you could also create that graph if you take notes from Jakob's amazing demonstration. Okay, so right now, here, let me share my screen real quick. I mean, we'll be taking a short break anyways, but yeah. Oh, okay, yeah. So we finished the demo, so we will be taking a short break. So that should say 7:05. So feel free to come back. You know, just get some water. You know, just do some stretches, and we'll be back at 7:05 with part 2.
Feel free to play some music, Chandra, if you want to.
Okay. Let's see what we got here. Opencv. Oh yeah. Okay. Part 2: standard libraries, Opencv, and TensorFlow. So this is what we have on the agenda. So let's get started with standard libraries. All right. Wait, I think there's something in the chat. Okay. All right. So the first standard library we'll be looking at in part 2 is sys. So this is a little different from OS, which you know, it kind of sounds similar, but this library deals kind of more with like a Python program while it's running, as opposed to like general operating system stuff. So like while you're running, you know, you might want to maybe stop your program, or you might want to like deal with some like variables that have to do with like a running Python program. And the sys library has like a lot of functionality that can give you support for stuff like that. So yeah, so you know, it has all kinds of stuff like command line arguments, you know, like input output, stuff like that. And we'll see a little bit of what sys has to offer momentarily. So what does this have to offer? So one of the most useful commands, at least I think, that at least one of the commands that I use the most personally is sys.exit. So whenever like, you know, you if you have like try catch blocks, for example, in your Python code, and you just, you know, encounter something which just makes you want to exit the program, you can just do sys.exit, and it'll just shut off the program the second it reaches this line. So it's pretty useful if you ever want to do something like that. And then we have sys.argv. So this is kind of like how you can take in input arguments from like whoever's calling your Python program. Like they could enter additional arguments after calling your Python program, and you could access those arguments using sys.argv. So you know, this is just something to look into in the documentation if you feel like you want to do this. And actually, we will like give you a much better alternative in just a couple slides. But yeah, that is always there for use. And then there are the trifecta of file descriptors: stdin, stdout, and stderr. You may have heard of these from different classes. These are pretty common in computer science, having what are they? We'll go over them one by one. So stdin is kind of like it's a kind of like a place where you can take in input from a person who's using your Python program. So they can enter stuff while the program's running, and you'll be able to access whatever they entered inside the program. So it's a little different from argv, because argv is before your program starts running, they can like add options and stuff. But stdin is during the execution of your program. And stdout is kind of what print uses. So you've like in previous learn.py workshops, you might have encountered the print command where you can like print something to the terminal, and that's like stdout. It's kind of like a fancy way of doing that, where you just you can like send like characters or strings or whatever to the terminal. And stderr is kind of just like similar to stdout, except you use it more for just letting people know that your program is like breaking in some way. Yeah, sorry about that. There's a phone going off in the back. Yeah, so the next thing we'll be looking at is Arg Parse. Sorry, let me just turn off the phone real quick. All right, sorry about that. Next thing we'll be looking at is Arg Parse. So we just learned about sys.argv, so now you can forget all about that because Arg Parse is many times better. It has a lot more functionality. Yeah, it's pretty useful for processing command line arguments. So yeah, how do you use it? You just do import arg parse, and then that'll allow you to use all of its functions and objects and other fun stuff. So yeah, it's just used for processing command line arguments that people might want to like if they want to like toggle something in your program, they can like provide an argument that'll tell your program how they want it to be run. So kind of like the general way that arg parse works is there's this main object called arg parse.argument parser, and with this you can use this object by first initializing it, and then you can kind of call its add argument attribute, which like its member function, which allows you to add like whatever custom arguments you want to add for your program. And after you add those arguments, you can go ahead and use the .parseArgs function, which will kind of like turn all the like that pretty complex string of arguments into something that's like easy to use, like a list. So yeah, that's kind of how that works. It's my professional recommendation to use arg parse as opposed to sys.argv, just because it's like it kind of like sweeps all the nasty stuff under the rug and makes it pretty easy to deal with option parsing. All right, so we got the standard libraries done. So now we will be talking about Opencv. Yep. Okay, so Opencv. How do you use it? It's a Python library. So you want to install it using pip, just running this command on your terminal. Pip install Opencv Python. If you want to do it using Python 3, you would want to do pip3 install Opencv Python. And inside your actual code, you'd import it as such. Import cv2 as cv. All right. Okay, so what is Opencv? Good question. Opencv is actually one of my favorite Python libraries, just because like you can do some pretty cool stuff with it. Like I use it a ton. It like there's like just a lot of like really complicated like computer science and like research papers that goes into making these functions. But I don't really know how that stuff works, and you don't really have to worry about that. You can just kind of see like the end product of all those scientists who are coming up with all these crazy papers and stuff. So yeah, you can do a lot of cool stuff, and it's pretty easy to use too. So yeah, so Opencv is Python's computer vision libraries. That's what the CV stands for. And yeah, it's used for all things computer vision. So processing images, analyzing them, and you can even like create your own images and videos. And we'll see that in a little bit in our demo. And yeah, you can create not just images, you can create anything you want, anything your heart desires using Opencv. Yeah, and just a little bit of context for what you can kind of do with Opencv and computer vision in a broader sense. So here on the left, we have a picture of what you guys might have heard of like the Tesla autopilot, like self-driving cars and like other self-driving cars. So this is actually like what the camera sees. One of the self-driving car cameras, what it sees and how like it takes just an image and is able to like detect all this information from just the image. And you can definitely do something like this with Opencv. So it kind of like is detecting all these cars here, creating bounding boxes for the cars, and there's like a lot more cool stuff with this, such as like if a car is coming from an orthogonal street and it's not even in the camera, like these algorithms are actually able to detect those cars. It's pretty crazy. Like they may not even be in the line of sight. It's actually called non-line of sight imaging. I don't want to go too deeply into that, but it's just out there, and Opencv kind of gives you like a toolbox to access some of these interesting things. And another thing is facial recognition. So you guys might have seen like your phone. You just look at the phone and it unlocks. It's actually using computer vision, and Opencv provides a lot of facial recognition software. So yeah, cool stuff. Cool stuff. All right. So Opencv Images. This is like the basic data structure in Opencv, like the fundamental data structure. And what are they? Turns out they're just NumPy arrays. That's all they are. Images are just multi-dimensional arrays, and we learned Jakob taught us about NumPy arrays a little bit earlier, and you can use all those functions and stuff that you learned for those arrays. It all translates directly over here. So the arrays are three-dimensional. They have the rows, the columns, and the channels. So for example, if you had like an RGB image that was so and so pixels, it would be represented as a 3D array with these dimensions. And yeah, here's kind of like a SpongeBob like NumPy array matrix, I guess. So you can admire that. All right. Okay, so that's what images are, but how do you actually get them? How do you actually use them? So that's a good question. How you do that is there is this command called cv.imread, and it takes in one parameter. It takes in just the file path of whatever image you want to kind of interact with in your program. So here's like a little code snippet to kind of show how this is used in the wild, where you just have your imports, and then you just call the function cv.imread, and you pass in whatever image you want to pass in, and it will return and be stored into this variable img. And you can see that like the dot shape attribute of the image still works, because the image or img is just a NumPy array, and you can do dot shape to NumPy arrays. And here we can see the output of what this would print out. Yeah. Okay, so that's how you get images. But how do you actually like once you get your image, you do some fancy stuff to it, how do you actually view the image? So the way that you do that is you call the cv.imshow function, which takes in two parameters this time, because you want to give a name for whatever whatever image you're displaying, and you actually also want to pass in the image matrix. So those are the two parameters, and we can see on the right in the displayed image, like up on the top bar, it actually shows the title of the image. And yeah, so like there's actually three commands that are often used together whenever you want to like check what your image looks like. So the first command is cv.imshow, which actually does the displaying, but you also want to run the command cv.waitKey, because if you didn't run it, then it would just display the image and it would go and like execute a bunch of other stuff that you have in your program, right? So if you do cv.waitKey, it kind of like stalls your program and doesn't execute any further commands until you press a key, which kind of signals that like you're done with this image and we can move on and execute all the other code that you have. And after you press a key, it's going to go and execute the cv.destroy all windows command, And this is just kind of like a useful command in case you're displaying a ton of images in your program and you don't want like 50 windows just like clogging up your desktop space. So you can just destroy the display that you just rendered. And so we learned all that stuff, but let's actually see it being used. So we'll do a quick demo. All right, let me go to VS Code. But just to kind of give you guys just a general idea of what we'll be doing in this demo, we will be making a real life deep fryer, a meme deep fryer. So yeah, should be interesting. All right. I think you guys can all see my VS Code now. If you can't, just shout. But all right, a meme deep fryer. Wow, what a fascinating idea. How does one go about making a meme deep fryer? So before I start coding, or actually, yeah, I mean let's just get some of the basic standard stuff out of the way. So you got to import your libraries. You got to import NumPy because these are all NP arrays. These images are all NP arrays. All right, so got the imports. So the first thing that we want to do is we want to read in our image. Let's go ahead and read in our image using the cv.imread command that we talked about earlier. What is going on? I think my VS Code. Oh, whoops. All right, a little bit of lag. My computer is a little slow. Take some time, but yep. Let's go ahead and pass in the image path, and we notice that it's in the same directory, so you don't actually need to provide full path. You can just pass in the name of the image. So moment.jpg. Amazing. There we go. All right. So did this actually work? Let's go ahead and find out. So you might remember the way that you display images is cv.imshow, and you pass in. First thing you pass in is the title of the image. So this is a moment. Perfect. Now pass in the image matrix. Then you can we don't really have any other code executing, but we'll just do this just for purposes of demonstration. All right, so we got that. Let's go ahead and see what a moment looks like. Oh, wait, this is the wrong code. You'll have to excuse me. Wait, let me pause this just so my demo doesn't get spoiled. All right. Okay. Let's try that one more time. Opencv real. IMG is not defined. Wow. So remember, you got to define you got to make sure you're using the right variable names. Okay, well, I guess this is what a moment looks like. Yeah. All right, pretty cool. But this is not deep fried, and that's what we're here to do. All right, this is just a normal image, just perfectly run off the mill moment, but that's not what we want. Okay, we want a deep fried moment. So how do we do that? How do you deep fry an image? So it actually turns out that deep fried images, they occur naturally. So it kind of occurs like just when like you send an image to someone, you send a meme to your friend, and he like screenshots the meme and he sends it to somebody else. They like download the meme, and like it's just like every time you screenshot it, download it, it just gets like more and more pixelated and more like kind of like used up, where like the pixels start to kind of like corrode a little, and it just looks completely weird. Like a bunch of filters have been added onto it, kind of. So that's all a deep fried meme really is. But we can kind of simulate that over here by doing some stuff. So what stuff can we do? So the first thing that we can do is we can sharpen the image a ton. So that's like a characteristic of a deep fried image. It's very, very sharpened beyond beyond recognition. So so we can sharpen an image. So how does one go about sharpening an image? What does that even mean? Well, you would assume that sharpening an image is kind of like the opposite of smoothing an image. So let's try to smooth the image first, and then let's go from there. So there's a command called Gaussian blur, And also, throughout this demo, we might notice like some like commands that are a little weird that like you might not recognize. And that's actually one of the cool things about Opencv. There's a lot of like actual science and like research going on to making these commands and implementing them. But like we actually don't really need to worry about what this is actually doing. It kind of hides away, like kind of abstracts away all the complex science behind it, and we can just use the results without really worrying too much. And that's kind of the amazing thing about libraries in general. Like we can use all these like crazy science that people have already done for us, and we can use it to make our own commands that maybe other people will use in the future. So yeah, okay, enough philosophy. Let's get down to business. All right, source image. So yeah, so if you kind of hover over this, we see that it takes some parameters. It takes the source, k size, and sigma x. So like these kind of correspond to so like this thing is kind of like a like you can kind of think of it like a brush that you kind of like move over your image to blur it. So if the larger the brush is, the more blurred it's going to become. And yeah, and there's this other parameter sigma, but it's not too important what it does, because the higher the number, it makes it more blurred. So I guess that's all you really need to know. So let's go ahead and see if this actually worked. Frame. We can go ahead and delete that. Go run this bad boy. All right, it looks a little bit blurred. It's kind of hard to tell though. But anyways, we don't really want to blur the image, right? We actually want to sharpen the image. So how can we do that? So turns out that to sharpen an image, you literally just subtract the blurred image from the regular image, and it's gonna make it sharpened. So that's some computer vision knowledge, I guess. That's how it works. So we'll just go ahead and sharpen the image. And there is a function for that, of course, because Opencv has functions for everything. It's called add weighted. So this kind of just adds like two images together with different weights. So yeah, the first thing would be source underscore image. The weight, we can give it 1.5. And we want to subtract out the blurred image, so we can give it negative 0.5. So it adds up to 1. And yeah, and this also takes like a random parameter called gamma. It's not really too important what that is for the sake of the demonstration. So we'll just go ahead and see what we got here. See how sharp this image is. All right. So not gonna lie, it is not that sharp. It is actually not. I can't even tell the difference. So what should we do? How about we toss this whole thing to this gigantic for loop and just sharpen it a billion times? Maybe not a billion. Let's just start with 10. All right, but the important thing is we want to pass the output, like our sharpened image, back into the input, so we can like keep like kind of sharpening the same image again and again, and hopefully that does something. So let me just make a copy of the source image matrix. Got that. We'll just deal with the image variable from now on. This will be our primary deep frying matrix. All right. So, that's pretty sharp. Whoa. Okay. All right, we're in business. We are in business. This is already starting to come together. Okay. All right, we got a deep fried. We got a sharpened image. But I mean, it's not. I wouldn't call it deep fried. There's still more we can do. There's still more we can do. All right. So when you put something in a fryer, it kind of looks a little red, right? A little reddish. So how about we just make the redness of the image more, like increase the contrast of the redness in our image. And as you guys know, images in Opencv are kind of so wait, let me just comment this guy saying sharpen image. Okay, so images in Opencv are basically just like 3 slices of red, green, and blue images, and you put it all together and you get an Opencv image, right? So to sharpen just the red, we kind of need to extract out the red slice of our image, mess around with it, and then put it all back together, and theoretically we should have a reddened image, right? So the way that you can split an image into its color components is this command called cv.split. So take this, pass that bad boy in there, and you got three colors, supposedly. So let's go ahead and increase the contrast and also make the redness just brighter. So take the red, and then we here, let's define a contrast variable alpha equals I mean, what should we give it? Maybe like 2.2 or something, and maybe like 50. And I'll tell you where these numbers are actually coming from. It's not just completely random. There's actually a little bit of like insight into why I'm using these numbers. So let's go ahead and merge this image. cv.merge. So this again takes in those three slices as parameters. Yeah, okay, so let's just display this image. Let's see what we got right now. Okay, see, we got an error. That's what we got right now. Why did we get this error? The reason why we got this error is because it kind of comes back to how an image works in Opencv. So images are there's kind of two main ways to represent an image. The first way is all the values in your matrix are all integers from 0 to 255. So they're all 8-bit integers, because 2 to the 8 is 256. So and by the way, this number 256 is kind of just like a standard. It's yeah, they kind of just chose like a reasonable number that can give you a lot of variation in color, but also not take up too much memory. So that's where that number is coming from. But yeah, so that's one way, an integer. But another way is to just use a float of a normalized number from between 0 and 1. So yeah, you can kind of just pass in like decimals that live between 0 and 1. But what is not good? What is not good? What just happened right now is not good. Is we don't want to pass in decimals that are between 0 and 255, because that's just gonna it's gonna think everything is white. It's gonna think everything is like this merge functions, like the Opencv itself will tell you that this is not kosher. So what we got to do to fix this is we have to actually cast this whole matrix into 8-bit integers, and we can just go ahead and do that like that, as so. And this is again not even an Opencv function. This is just an NP array function. So like, yeah, okay. So let's see if that did something. Okay, so it works. It works. Looks a little redder. All right. And one other thing is you might notice that there's actually a bug in my code where let's say that a pixel was already 255, a red pixel. Now you're multiplying it by numbers and adding stuff to it, and now it's going to be like way higher than 255, right? But we don't want that. We only want everything to be between 0 and 255 for proper representation. So we can kind of just use the np.clip command to just make sure that none of our variables or none of our pixel values are anywhere outside of this interval. So that's what clip does. So if it's below 0, it'll set it equal to 0, and if it's above 255, it'll set it equal to 255. So yeah, so that's that. Okay, so we got we just increased the red contrast. Amazing. All right, so I think it's starting to come together. I think this is it's looking pretty deep fried. But there's always more we can do. Opencv just has so many crazy functions. There's always more, and more we will do. All right, why stop here? Let's just take it all the way home. All right, so one pretty cool function that Opencv has is called canny. So like what canny means. There's this dude named Canny who came up with this like wild function to detect edges in any image. So we can thank Canny for this demo. It's dedicated to our boy Canny. So we actually don't want to pass an image because image is like the completely deep fried like nasty thing which just has like edges all over the place, right? So we want to pass in the original, the OG broad momentum image into Canny in order to detect the edges. And it does take in 2 extra parameters, which kind of like what is an edge is kind of a subjective thing, right? But it can be made objective if you pass in a number which tells you how closely to yeah, like kind of like what your threshold is for what you think an edge is. So the higher this number is, it's gonna let in a lot more edges. The lower the number is, it's gonna it's gonna have to really be an edge in order to be considered an edge. So let's actually see what I'm talking about here. Let's see what the edges look like. Edges cb.weight key 0. All right. Got the edges. See what they look like. All right. Wow. Amazing. These are our edges. Yeah. Okay, so we got the edges. So the reason why I even wanted the edges was I kind of wanted to make like the image, pop out a little more, just for the full deep frying experience. So what we can do is we can actually add. We encountered the add weighted function earlier. We can actually add the edges to the image. And I noticed that I am running a little bit out of time, I think. So I will try to speed this up. Okay, so we want to make the edges red because in line with the deep frying theme. So let's just go ahead and define an empty array which is of size the original image, and we can go ahead and because you notice that when I displayed this image, it was black and white, right? That's because it was just one color channel. So now we want to add in 2 other color channels, green and blue, which are just empty. So and we just populate the red color channel with our edges. So then it's just going to look red, right? So we can kind of index this matrix with like so. And this might be a little different from what you guys have encountered earlier with matrix splicing, but it works pretty similarly. You just say that you want the second, or it's 0 index, so the third slice of your image, or the third slice of this matrix, and you just go ahead and set that equal to edges. Right. So, I mean, now let's go ahead and see what it looks like. See if it actually worked. And this is again kind of like just driving the point home of how Opencv images are literally just your regular run off the mill NP arrays, and you can like do whatever you want to them. You can just manually just go in and set pixel values, and it'll still like show your image the way that you set it to be. So yeah, so we got that, and now we want to what do we want to do? We want to combine the edges and the we want to combine the edges, and we want to combine the original image. So let's go ahead and do that. So we can just make it half and half. All right, so just combining that. So yeah, let's try that out. Or wait, I can actually close this. And we seem to have some sort of error on this line. Okay, well, one thing that we do have to do is let's just go ahead and see why this error is happening. Let's print out this red edges matrix. So it's actually the reason that we encountered earlier. where we have to make sure that our values are not floats. So that's very important to keep in mind. Your typing should be consistent with what you want. So just go ahead and cast this to 8-bit integers. Then this should be good to go. All right. Okay. Well, I mean, we got the bolded edges, but the whole thing looks a little dim. So let's make it a little brighter. So we can actually go ahead and do what we did earlier. Bold the edges. Okay. So yeah, we can go ahead and do what we did earlier, where we kind of split the image. Or actually, we don't even need to split the image. We just want to make the whole thing brighter, right? So we can just go ahead and like increase the contrast just a little bit, and also add like some constant to all the pixels, so everything just gets brighter. Okay. So, and again, have to make sure that it is cast properly. All right. So got that. Okay, wow. This looks very dank. This looks like a respectable deep fried image. Yeah, I'm very proud of the work we did here today, guys. So if you want me to send you the image for you to frame at home or something, feel free to hit me up. But yeah, that is all for the Opencv demo. So I will go back to presenting the slides. Okay. Wait, are there any questions in the chat? Thank you, Canny. Yes, thank you, Canny. All right. All right. So we got funky. We finished the demo. Now let's get back to what else we have in store for today. Yeah, and by the way, if you want to learn more about Opencv, if you liked what you saw, feel free to hit up this documentation. It's pretty good. They have some more tutorials. They have some like commonly used commands. They'll give you the rundown right over there. So all right, we did standard libraries. We looked at some deep fried images in Opencv. Now on to TensorFlow. TensorFlow. Okay, TensorFlow. What is it? It is a machine learning library that is written in Python and C++. But we don't care about C++. We only care about Python because this is not learn C++. Okay, so what it actually does is it kind of allows for somewhat easy use of machine learning models to develop them, to train them, and to utilize them for whatever application you have. And it is integrated with Keras, I think as of like 2 years ago, which is a like higher level sort of neural network API. So you might notice that a lot of the function calls in TensorFlow are actually just like called through Keras. Just a fun fact. But what is machine learning? So machine learning is I mean, as the name suggests, it's machines learning. So they analytically, based on like patterns in the data, they like make better predictions and better analysis without human intervention, or with minimal human intervention. So yeah, so it just looks at patterns and it makes decisions. And it's kind of like the big thing nowadays. You might have seen it around, artificial intelligence, machine learning. So here's what it is, with less fluff, hopefully. So yeah, so this is kind of like how these different buzzwords all like are related to each other. So you have like your overarching AI, which like is very, very broad. It's all just about like anything that is non like what is it, biological life, anything that's like capable of learning, kind of what it is. And machine learning is kind of like a subset of AI. So it's a little more specific of learning from data and like building like models and stuff based off of data. And deep learning is even more specific. So it's specifically using neural networks where there's a lot of like layers in between the input and output. And by the way, this goes for like what I'm talking about now, and also for my the demo that we'll do in a little bit. This is all very highbrow stuff. So don't feel if you're starting to feel a little lost, don't worry. The whole point of this demo is not really to teach you guys machine learning, but it's more to just show you guys that this exists. And not only does it exist, it's accessible in Python. So it's just kind of like a sneak peek. Yeah. So don't feel like you're out in the deep end. It's this is pretty complex stuff. But yeah, let's get started. Just a very, very high level overview of what how TensorFlow works. So yeah, so the tensor in TensorFlow is one of the fundamental data structures that are used. So all they are just multidimensional arrays. Kind of sounding like Opencv over here, but they're just multidimensional arrays that all have the same type. So here we have a representation of various tensors, and they are all differing by rank. So a rank is kind of like the dimension of the tensor. Yeah. So that's that. And what is flow? Where does the flow come from in TensorFlow? So the way that these TensorFlow programs, these machine learning programs work is they kind of absorb in tensors and they move them around. They kind of shift it a little bit. They do stuff to it, and they turn it into other stuff. So it's basically kind of like the flowing of tensors, you might say. You can represent every single TensorFlow program as this kind of graph where the edges are the tensors, and then the nodes kind of define different operations that you're performing on the tensors. And again, try not to get too bogged down by this stuff. And yeah, and for this demo, feel free to kind of just sit back and watch, and yeah, I want to be coding this. I'll just be kind of showing you what can be done with TensorFlow. That being said, we can go ahead and get started. Let me pull out the TensorFlow demo. Okay. All right. Let's see. You guys can see this Jupyter notebook. So for this demo, we will be showing you guys a machine learning model on clothing. So this is the data set that we'll be using. All kinds of clothes. See if you can spot your fit here. Got some shoes. We got some purses. Got a ton of clothes. And the goal of this demo is to see if you can you pass in an image of some sort of clothing, and can you figure out what that clothing is? Can this program figure out what this clothing is? So that is the goal of this thing. And the reason why it's machine learning is because one school of thought would suggest that you just come up with this crazy algorithm that has all this information stored of what defines clothing, and it analytically or algorithmically figures out what type of clothing it is. And that, as you can probably imagine, is really, really complicated. So it's extremely hard to do something like that. But if you use machine learning, on the other hand, it the computer kind of just keeps trying to minimize the specific function called the loss function, which we'll kind of briefly talk about later. But it makes the code a lot simpler and gets you results as opposed to doing things kind of in an algorithmic way. But yeah, so there's this gigantic data set by by this organization called MNIST. They actually have a ton of data sets, and machine learning just runs on these. You just have to feed in these huge data sets, and it's going to start to find patterns that we even aren't able to see across these data. But yeah, so we got the different classifications here that this program should try to figure out what an image belongs to. So let's just go ahead and start running this program. All right. The last time I ran this program, it was a little laggy because my computer is not great. So, all right, so we're in business, it seems. Yeah. Okay, so this is just kind of a closer look at what kind of like clothing types we have, various stuff. And it's also a little grainy. So the reason why they made it so pixelated is because there's just so much data that they have to like conserve space, or else it just get like computer would just explode with all this data. So they tried to like make the images as lightweight as possible. But it's also kind of impressive. Like, I might have a hard time figuring out what like this thing is, and ideally this computer or this program should be able to classify these images. So yeah, so there's like some commands like, setting up the neural network layers. Yeah, but again, like we kind of just want to see like how cool this thing is. We don't really want to go into the nitty gritty here. So let's go ahead and running. Yeah, you kind of like see this like variable called loss, which is slowly decreasing. So that means that as the model is being trained, it is getting better and better by kind of finding the global minima of its predictions. So it's getting more accurate. So let's actually see if it is getting more accurate, and voila, it has accurately detected an ankle boot. And other shoes and other stuff. It has very accurately detected this stuff. So this would be like a very, very difficult to do without machine learning. But with machine learning, you can do all kinds of crazy stuff like this. Yeah, you can do it with TensorFlow. So yeah, I just want to show you guys what is possible out there, what you guys can do. So if you guys are interested in this, you should definitely hit up ACM AI. They are the ACM, like machine learning, all things artificial intelligence committee, and they actually give workshops on the stuff. So you can actually learn how the stuff works behind the scenes and also write your own programs. So I would highly, highly recommend going to ACM AI to learn more. So that is the demo. And not only ACM AI, but also you can go directly to the horse's mouth at TensorFlow documentation at this website. All right, so that concludes our workshop. I hope you guys learned something useful, that maybe in a couple years down the line, or you're working on some project and as Jakob said, you just pull out one of these libraries and start going crazy. But yeah, thank you for coming, and feel free to fill out this feedback form. We really appreciate your feedback, and we try our best to iterate on it. But yeah, thanks for coming. That concludes the workshop.
Just as one final note, just from the learn.py team, we just want to say thank you to anyone who's here right now, who's watching the recording, and has been attending, like whether it's just been one workshop or all of the workshops. We're really thankful to see you guys supporting us, and we hope that we can see you guys in future hack workshops as well. And just one final note before we go. As far as raffle winners are concerned, you'll be getting an email in the coming weeks, if you won the raffle. So stay tuned for that. And one big final thank you again.